Hello students, hope you are all fine. So as in the last class I explained you histogram, which was a part of central tendency, right? And also I've told you that the remaining two exercises of chapter 21 central tendency will be doing once we are back to school. Okay. Now we are going to start a new chapter. As you can see on the screen, it's quite interesting. It's mensuration, right? This is going to be interesting because students, here you have the direct formula based questions, the concepts, okay? Only the basic formulas you need to understand, and then the application of the same you can practice and understand, right? So before I start today the exercise, chapter 17 mensuration, let's discuss what are 3D shapes. See, in our life, we come across many shapes, like the shape of a pipe, okay, a spherical cricket ball, or cuboids. These are all 3D shapes, right? Because they have length, breadth, height. Or I can say they have capacity, they have volume, right? So we are going to today discuss about the concept of surface area and volume of various shapes, okay, like cuboids, okay, cone, cylinder, sphere, hollow sphere, etc. Right. In today's class, we are going to understand firstly the meaning of few basic terms. Let's understand for any solid figure, whether it is a cone, it's a cylinder, or it's a sphere. Let's understand the meaning of the basic terms. First is the volume. See, if you have seen a chalk box, because it's a common example, okay. If I see a chalk box, what is inside it? Chalks are there, right? So the capacity of that chalk box to hold the number of chalks is basically the volume, right? Similarly, if I consider a cylindrical jar, then the capacity or the quantity of liquid that can be filled in it will be calculated always by finding out the volume of it, right? So that is what we mean by volume, the capacity measurement of any solid figure. Okay, now what do I mean by solid? I'm again and again repeating solid figures and giving you the examples also. A figure which occupies a portion, a space enclosed by a plane or curved surfaces. Because when I say cylinder, it's a curved surface, right, students? Next is the surface area. Whenever we use in the question surface area, it would mean only total surface area. Okay. Other than that, if I use any other term like lateral surface area, curved surface area, then that is different. For total surface area can also be used. Now, what does it mean? Total surface area or surface area? They actually mean the sum of areas of plane or curved faces of any solid, right? Let's start today's class, students. Okay, we are going to start firstly with the cylinder. You all have seen cylindrical pipes, cylindrical containers in which you take either milk or something else, right? Now what all is it having? See the screen of the sheet which is there in front of your eyes. What's the shape? Yes, rectangular. If I take out a page from my notebook, the sheet is rectangular in shape. That means it will have a length, okay, it will have a length and it will have a breadth, width also. Now once I roll it up, let's start rolling that paper, okay, and let's join this particular breadth with the another one. What will be formed is basically is this shape cylinder, students. You can try it out right now also. It's so easy. Take a single sheet, okay, right? And that sheet is obviously rectangular in shape. Fine. When I join it breadthwise like this, I roll it up and I join the two breadths. What do I get? I am able to form a cylindrical shape. So basically the length of that rectangular sheet, here I am talking about this, students, that this length of the rectangular sheet forms what? The circumference, the boundary of this cylinder. The cylindrical shape is having a circular top and circular base also. And when I roll the sheet, this length of the rectangular sheet will form what? It will form the circumference of the circle, right? So, what is the formula for circumference of circle, students? 2 pi r. You've studied circle in your previous junior classes. Circumference of circle is 2 pi r. So that means length of that cylinder in this case, when I fold it, when I roll it breadthwise, okay, then in that case the length of this rectangular sheet will become the circumference of this cylinder. Fine, clear? Now what about the breadth? The breadth will remain as the height of the cylinder. If understood this much, now we are in a condition to talk about all the three formulas. We're going to talk about the three formulas, three major formulas. What are they? Lateral surface area, that means the curved surface area. This is the curved surface area, right? Next, the total surface area, and the last is the volume. Volume means capacity, total surface area, I've already explained you. And then let's talk about one by one the curved surface area will begin with. First is curved surface area. Okay, if I talk about the curved surface area, then this is what it means, right? So what are we having in it? This is having 2 pi r as its value. This total is 2 pi r, the circumference. And what is it having? Height. So what is the formula for this curved surface area? It is length into breadth for rectangle. So for cylinder it becomes 2 pi r into h, which is 2 pi r h. What is 2 pi r? The circumference of the circle, right? And h is the height. So we get the curved surface area of cylinder as the formula 2 pi r h. Square units because it's the area. Total surface area, for that I'll have a circular base also, because that is also there. So then it will have curved surface area 2 pi r h, which I have just now explained you, plus how many circles it is having? One circular top and one circular base. Area of circle is pi r square. So it adds up and gives 2 pi r square. So if I take 2 pi common, 2 pi r common, I get this expression as 2 pi r is taken common, total surface area. Now we can learn the formula as 2 pi r bracket r plus h square units. Let's talk about the next, that is the volume. As I told you, it's the capacity, it's the quantity of that, or we can say the space occupied, right? So that volume is always equal to pi r square into h, because what is the area? If I fill water into the cylinder, tell me students, will I take the top also? No, you have water tanks at your home, right? So they are cylindrical in shapes also. So the base will have the water first. That means pi r square is the area, that base will be covered first, that circular base will be covered. So pi r square, and h height, to that the water will be raised. So what's the capacity? How much water can be filled in it? Pi r square h. So what is it? Pi r square h. Clear students? Clear? So these are the three formulas, and also we understand here, we are going to discuss quickly the formula for hollow cylinder also. Students, when I talk about the pipes, cylindrical pipes, what do you know about it? Yes, what we know about it is that they have smaller radii, the inner radius, and outer radii, the capital R, the radius. So accordingly all the formulas will vary. I'll quickly discuss. In that case, the thickness of the pipe will be equal to capital R, the bigger radius, minus the inner radius, that is smaller. So thickness of that cylinder, hollow cylinder, is capital R minus small r. Students, you have to write all the formulas. I'm not expecting you to write whole of the definitions and everything. No. But all the formulas must be written before you start the exercise. So what is the thickness of a hollow cylinder? Capital R minus small r. Then comes the area of cross section. Area of this is, complete cylinder is bigger, pi capital R square. For the inside cylinder it will be pi small r square. So I can conclude it as pi capital R square minus small r square, right? Similarly, total surface area, we will add up all 2 pi bracket RH plus smaller h plus r square minus r square. That means I'll be adding the area of the bigger two circles, smaller two, okay, and then accordingly we'll get the volume. Last comes the volume. Volume is pi r, capital R square and small r square are there. So pi as it is, capital R square minus small r square h. Formulas are all there. I would actually suggest you people do not start exercise before the formulas, okay? Now let's start with the exercise, okay? So we have the first question is homework for you all. It is given in the exercise before starting that pi you have to take everywhere 22 upon 7. So take it accordingly. If it is given in the question to take, we all know the value of pi can be 22 upon 7 and in decimals 3.14. So if it is given in the question, good enough students, right? If it is given in the question, good enough. Take that value 3.14. Otherwise, it's written clearly, take pi as 22 upon 7 unless stated otherwise, right? So for the first question, pi is not given, we'll take that. Okay, in terms of pi, we have to give the answer. That is your homework question. Question number 2, let's start with it. An electric geyser is cylindrical in shape. Fine. Having diameter 35 centimeter. What's the diameter? 35 centimeter I've written. So radius is half of that. You all know? Radius is half the diameter. So 35 upon 2. Height 1.2 meter. Now this value is in centimeter, students. This we do in physics also. If one quantity is in centimeter, the other should also have the same unit, that is centimeter. So convert it. 1.2 into 100, 120 centimeter. Now the first part of the question says, neglecting the thickness of the walls. We need not have to consider that. We have to tell outer lateral surface area. What's the formula for lateral surface area? Curved surface area. 2 pi RH. 2 pi 22 upon 7. R half of the diameter 35 by 2 and H 120. So substitute all the values, centimeter square, because area is what we are talking about, and the answer comes 13,200 centimeters square. Next part, they are asking us to also find the capacity in liters. Students, here it should be very clear to you. Capacity means what? Volume. Again I am repeating, capacity means volume. So pi r square, H is the formula we discussed. Pi 22 upon 7, r square, we have substituted, and H is here. So what do I get in centimeter cube, because it's the volume, right? Clear? Now how to convert it into liters? Divided by 1000, right? Clear? So that is what it is, divided, what do I get? 115.5 liters. Third question, students, is your homework. Let's see the fourth question. Figure is given to you. A rectangular foil was having dimensions 22 centimeter by 16 centimeter. 22 centimeter by 16 centimeter. That means the length was given as 22 centimeter. You can see the figure given in your book. Rectangular foil. I have explained you in the beginning of the class. Rectangular sheet. Fold it. Okay. What's the breadth? It is given 16 centimeter. Is wrapped around to form a cylinder of height 16 centimeter. Is wrapped around. So how is it folded? It's folded lengthwise. Student, this is very, very important. How is it folded? Okay. So now when it is folded, you have to find out, the question says volume. Before I find out the volume, I will recapitulate the formula. What's the formula for volume of cylinder? Pi r square H. Now in the question, neither the radius nor the height is given. But I know one thing. For this rectangular sheet, when I fold it lengthwise, the height will be same as that of the breadth. I explained you, students, this will become the height of the cylinder when I folded this lengthwise, right? So this 2 pi r, that is the circumference of the circle, will be equal to the length. So here I have used the formula 2 pi r equals to 22, which is the length, which gives me radius r as 22 upon 2 pi. Put the values. What do I get as the radius? 7 by 2. What's the formula for, what is the value for pi? 22 upon 7. So 2 and 11 it get cancelled. So 11 is left. Pi value is 22 upon 7. So 22 here and 7 here, because denominator mein tha beta pi. Substituted. Pi r square h. Pi is 22 upon 7. Radius r square into h height. Height will be what? It will be the breadth of the rectangular foil, because it is folded like this. Okay, like this. This was question number 4. Fifth is homework. As students, I am taking the E1 as classwork. Okay. Fifth is homework. Sixth question says, a road roller. You all must have seen road roller. Yes, road roller you all have seen. What is it? Cylindrical in shape. Perfect. So a road roller, which is in the form of cylinder, has diameter 0.7 meter. Diameter is 0.7. Radius half of it, 0.35 meter. Very good. Width is 1.2 meter. So width will act as what? The height only. So height becomes 1.2 meter. Height is given, students. Height is given, students. Okay. And we are also given, height is given 1.2 meter, which we are taking as the width. Okay. Radius 0.35. First of all, the questions, as per the question, we are supposed to calculate, find the least number of revolutions. Now this road roller, if suppose this is the ground, this is the road on which it is supposed to roll. Okay, the way if I consider a pencil which is rolled on my hand, see, if I consider the surface is rectangular in shape and a cylindrical object is to be rolled over it, how many times that cylindrical object will take turns, that means the number of revolutions, so that it covers the whole of the rectangular area? Yes, because the area of the rectangular ground will be more, L into B, and the curved surface area. Why curved surface area, students? This needs to be clear, be very clear. See, when a road roller is moving on a road, imagine that, so easy to understand. A road roller when moving on the road, or a pencil when you roll it on your rectangular sheet, what part of the cylinder is coming in contact with the rectangular ground? It is the curved surface part. It's the only external curved part, right? Is it that the volume? No. Is it that the total surface area? No. It's only the curved surface part, that curved part which is coming in contact. So firstly, I'll calculate the curved surface area of the cylinder, because that is the area which the cylindrical road roller will cover after taking one revolution. In one round complete, this is what the road roller will cover. Clear? Why have I taken curved surface area as that part? Clear, students? Okay, so 2 pi is 22 upon 7, radius r is 0.35 into height is 1.2. Substituting all the values, I'll be able to calculate the curved surface area of the road roller. Now, also I've told you the area of the ground. The ground dimensions are 120 meter by 44 meter. As I said, it is rectangular in shape. Length into breadth is the formula. Length into breadth is the formula for area of rectangle. Right, students? Area of rectangle is length into breadth. So, what is the number of revolutions? We know the ground surface playground will be having more area. So, area of playground upon the area of cylinder, curved surface area of cylinder, that gives me, on calculating, number of revolutions as 2000. So when 2000 times the road roller will roll, it will cover the total area of 5280 meters square of a playground, rectangular playground. Clear? This was sixth question. Let's move to the next. Students, now 7, 8, 9, 10 are all exactly same. So I'm giving you all that as homework. Okay, let's take this next question. This is interesting question because here we are taking the barrel of a fountain pen. Earlier, very many people used to use it. Okay, fountain pen, and inside that, if you have seen, any one of you have seen that tube, that is actually cylindrical, in which the ink was filled. Right? It used to be refilled again and again. So the barrel of a fountain pen, cylindrical in shape, is 7 centimeter long. What's the height? Long length of that cylindrical barrel, that is the height, that means 7 centimeter it is given, and 5 millimeter in diameter. So the diameter is also given 5 millimeters. Diameter is 5 millimeter. Now students, tell me one thing, is it that you will start the solution? No. Here it's centimeter, here it's millimeter. Convert millimeter into centimeter. You all have seen your scale. 1 centimeter is 10 millimeters. So convert it. Okay, firstly this is diameter, so half of that is radius, 5 by 2, and then to convert it into centimeter, divide by 10, I get 1 by 4, or I can take 0.25 centimeter as the radius. I repeat, this is the diameter, radius is half of that, so 5 by 2, and to convert it into centimeter to make the unit same, divided by 10, which comes out 1 by 4. Okay, now question further says, a barrel full of ink will be used up when writing 310 words. Number of words we are given that 310 words are written. So barrel is filled means what will be filled inside? Capacity. Volume we are talking about, the ink filled in it, volume. So volume formula is pi r square h. Pi 22 upon 7, radius r square, 1 by 4 into 1 by 4, and h height was 7 centimeters. So substitute all the values, I get the volume of that cylinder, cylindrical barrel, as pi r square h, which is 11 by 8. That's fine. Now ink in the bottle. See the question. How many words would use up a bottle of ink containing 1/5 of a liter? There is a bottle of ink. How much ink it is having? 1/5 of a liter. 1 liter is 1000 milliliter. Correct? So 1 by 5 of liter means 200 milliliter. 1 by 5 into 1000, this is clear? 1 by 5 into 1000, 5 2s are 10. So 200 milliliter, this part is clear? This part is clear? Now volume is 200 milliliter means centimeter cube. This much is the volume that we have of ink. Okay. And this much is the volume of ink which is used in the barrel of fountain pen. And 310 words is what they are saying. On an average, the barrel of ink can write. Clear, students? I repeat, how much is the total ink we have? 200 centimeter cube. Total ink. And one barrel once filled, 11 upon 8 centimeter cube. This much volume of ink comes inside it. This is the total ink we have. This much is the volume. So divide the two. Divide the two. Okay. Number of work written by this ink will be this multiplied by 310 words. Because in the question I am reading it out again for you. A full barrel ink can write how many words? 310. So for 200 total ink, 200 divided by this volume of one barrel, divide, so 11 upon 8, they say it goes in the numerator. Clear? And why 310? Because for one barrel of ink, I can write how many words? 310 words. So what do I get? On dividing approximately, I will get this value. Students, also one thing to be noted in the question, they are saying answer correct to nearest 100 words. 100 words. So round it off in terms of hundreds. Yes, 90.9. It will be rounded off to 100 means it is close to 100. So 45,100 words can be written with this much ink. How am I getting 200 centimeter cube? Because 1/5 of a liter, 1 liter is 1000 milliliters. So 1000 से multiply करो इसको 1/5 into 1000 which comes out 200 milliliter or 200 centimeter cube. Okay. This was question number 11, students, right? So this was it. Last question, question number 12 I'm taking, and we'll be winding up the class right after this question. See, students, pay attention. Question number 12, what it says? Yes, it says, yes, find the ratio between the, after this I'm taking 12, please pay attention, students, look into your book. 11th I've just now explained, and I'm taking question number 12, what it says. Find the ratio between total surface area. What's the formula for total surface area? 2 pi r bracket r plus h. Find the ratio between total surface area and curved surface area, students. Curved surface area, what's the formula? 2 pi r h. So the two formulas are clear. Total surface area 2 pi r bracket r plus h. Okay. And curved surface area 2 pi r h. As I said in the beginning also, once the formulas are learned, students, you won't find any difficulty in doing the solutions, right? But the formulas must be on your tips. Okay. Question says to find the ratio of total surface area and curved surface area. Height and radius are given in the question. What's the height? 7.5 centimeter. Radius 3.5 centimeter. So substitute the value. Why am I not putting the value of pi? Can anyone tell? Think of it. Because in both the formulas pi is there and it will get cancelled. Okay. So 2 pi r is 3.5 bracket r plus h, 3.5 plus 7.5. It's 550, 7 3 10, 10 plus 1 11. So 7 pi into 11 which comes 77 pi centimeter square. Okay. Students, if you will put the pi and then you will cancel it, then also it means the same. So better is to go with the easy method. Do not put the value of pi. Let's cancel it out. We know in both the formulas pi is there. Right. Next, 2 pi into r into h. R is this, h is 7.5. So what do I get? 7 pi into 7.5. This I have calculated 3.5 into 2. Excuse me. Now the ratio, pay attention, student, it matters a lot. Ratio of A to B or B to A. Order totally gets changed. So pay attention, the question says ratio of total surface area. So what will I come first? I'll take the first is the total surface area value, 77 pi. With curved surface area, so next comes is the curved surface area. Divide the two, pi cancel, 77 upon 7. 11 is left in the numerator upon 7.5. 7.5 I have written as 15 upon 2. Now we all know how to write it in standard form in ratio proportion. First exercise, beginning questions you did it. 11 2s are 22. Multiply both the values by 2, it comes out 22 ratio 15. Hence the ratio of total surface area 2 pi r bracket r plus h with the curved surface area 2 pi r h comes out 22 ratio 15. Is that clear? Your homework is complete exercise 17.1 up till question number 13. I repeat, your homework is to complete exercise 17.1 menstruation first exercise up till question number 1 3 13. Thank you, student. Revise the formula so that in the next class it becomes easy for you to